So we can turn text into vectors and measure how similar they are. But a real system might have millions of these vectors, and it needs to find the closest matches to your question in a fraction of a second. A regular database isn't built for that. So a whole new kind of tool exists for exactly this job. Today, the vector database. Welcome back to AI in 5. Here's the one-line version. A vector database is a specialized store designed to hold embeddings and search them by similarity. Normal databases are great at finding exact matches, this exact name, this exact ID. A vector database is built to answer a fuzzier, more human question: what's most similar in meaning to this? That's a totally different job, so it needs a totally different tool. For each piece of content, it stores 3 things. The vector, that list of numbers capturing the meaning. The original text itself, so you can hand it back to the model later. And metadata, useful tags like which document it came from, the date, the author, or the page. That bundle, meaning plus text plus tags, is what makes a vector database so handy for retrieval. Let's contrast them directly. A regular database answers precise questions. Show me all orders from May 3rd. Give me user number 42. Exact, literal lookups. A vector database answers: show me the passages most similar in meaning to this question. One works in neat rows and columns of facts. The other works in a cloud of points in meaning space. Different questions, different tools. And the real magic is speed at scale. Comparing your question to 10 million vectors one by one would be painfully slow. So vector databases use clever indexing tricks, often called approximate nearest neighbor search, to zoom in on the likely closest matches without checking every single one. The result: you get great matches back in milliseconds, even across millions of items. That speed is what makes RAG feel instant. It works in 2 phases. Ahead of time, the loading phase, you embed all your documents and store their vectors in the database. Then, at question time, the search phase, you embed the user's question and ask the database for its nearest neighbors. It instantly returns the top few most similar chunks, along with their original text. Load once, search forever. That stored, ready-to-search memory is the heart of RAG. You'll bump into a bunch of names here: Pinecone, Weaviate, Milvus, Chroma, Face, and Vector, which bolts vector search onto a regular Postgres database. Some are managed cloud services, some you run yourself, some are tiny and free. Don't get lost in the brands. They all do the same core job we just described. The concept is what matters, and you've got it. So why does this matter for RAG? Because the vector database is the AI's long-term, searchable memory, the place that actually holds all the knowledge the model itself doesn't have. Your company docs, your help center, your notes, all sitting there as searchable meaning. And you can add or update entries anytime, without retraining anything. Fresh knowledge, instantly searchable. That's the dream we set up 2 days ago. So picture the vector database as a vast, beautifully organized library of meaning. Every passage filed not by title or date, but by what it's about. Ask a question, and it hands you the most relevant pages in an instant. That's the engine room of every serious RAG system, quietly storing and serving meaning at scale. So a vector database stores embeddings and finds the nearest matches fast, giving RAG a searchable, updatable memory. But there's a question we skipped. What exactly do we store? You can't just dump a whole 500-page manual in as one giant vector. Tomorrow, we learn the art of chunking, slicing documents into the right size pieces. See you tomorrow on AI in 5.